Alright folks, this is number 2 on Unit 3's concept list. Okay, both of these are talking about solving for the constant, but in general it's working with problems of applications dealing with where you have to both integrate and find a constant given some information. Okay, so let's look and decide why it says to integrate. It says determine the cost function if the marginal cost function is this. Okay, we talked about this before, but when you see this word marginal cost, it's talking about the rate of the cost. And another thing that says that right here is that notation telling you that this is the derivative or the rate function, and we're going to have to find the actual cost function. Okay, and it tells us that. Then it tells us another piece of information. It says 2 units of the item X costs $5.50. So that's giving us an ordered pair, 2 for our X value and $5.50 for our Y value. Anytime that's happening, then there's some constant that we have to go solve for. And a lot of times the constant they'll give to you by giving you what the X value 0 corresponds to. But if it's a number other than 0, we'll have to solve for it. Okay, so let's look at this equation. They gave us that the derivative was x plus 1 over x squared, and anytime you can rewrite to help yourself if you aren't sure of the pattern when it's x squared on the bottom, just go ahead and rewrite it. Okay, so this is the same as saying x plus x to the negative second power, and then when we integrate that, we're just doing both pieces with respect to x. Okay, so this piece here, using your power rule, we're increasing by 1 and dividing by that same number. Okay, same thing over here. We're going to increase by 1, negative 2 plus 1 is negative 1, and we're dividing by that number. Okay, plus some constant. So here, if we rewrite just a little bit, we have 1/2 x squared. This is changing to minus, then it's 1 over x to the first. You don't really need that first, but it helps you see where that went to. And now we're at a point where we know the cost function, and we're ready to solve for that ordered pair. Okay, so now that we know the cost function, we have this x and this y value that we can substitute in. So the y value goes in right here for $5.50, and then we're subbing everything else in. 1/2 of 2 squared minus 1/2 plus this constant. Okay, and you can do a lot of this in your calculator, but it's kind of how you want to solve it. Okay, so I'm leaving this $5.50. 2 squared is 4. 4 times 1/2 is 2. And 2 minus 1/2 is 1.5. Okay, this whole thing could be thrown in your calculator. Okay, and because this right here is 1.5, okay, we're subtracting 1.5 on both sides. Those cancel, and it tells us our constant is 4. So putting it all together, we've got c of x equals, okay, this part right here, the 1/2 x squared minus 1 over x, and then our constant was 4. And that's it. Okay, let's check out the part B for this problem. Okay, so this time it says the rate of growth of profit in millions of dollars, this is going to be super important for us, from a new technology is given by this function. Okay, so again, when we're talking about recognizing when this is telling us to integrate, is you have to know that this is a marginal something or it's a rate of something. Okay, and things like marginal, rate, or the notation is telling you that. Okay, so get used to looking for those items. Then it says X represent time in years. Total profit in the 3rd year of that new technology is $10,000. Okay, so here's the big part of where people go wrong on this problem. Okay, we're given an ordered pair just like last time. Okay, but we have to be careful because of this in millions of dollars. Okay, so we've got our 3rd year, that's just 3, okay, because we were told X went with our years. But this 10,000, we have to think about in terms of millions. Okay, so you just take that 10,000 and you put it over 1 million, And this is another thing you could type in your calculator, but I'm just going to get rid of some zeros here. So 3 goes with 3, then I can get rid of one more. That's 1 over 100. Okay, so 100th. Okay, and then we are going to go sub some stuff in here. So we're starting with recognizing that the equation given to us is a product. Okay, I know that because when I see this x and the e, they're being multiplied together. Okay, so that's a product because two different pieces are being multiplied together that have x. Okay, and when there's a product, remember you want to use u substitution to go simplify. So here, we're going to let u equal our power. We talked about that in my u substitution video. And then we're going to take the derivative of that. And derivative, that power goes down, negative 2 x to the first. Okay? So now that we know this information, we're going to replace this thing because we're going to find the integral of that with respect to x. Okay, we're going to replace that thing with our u variable so that it matches this exactly. So I know e to the u is happening, but I also have to make this x happen from here. And hopefully you can see that to get from this to this, you have to multiply by negative 1/2. Okay, but we talked about there's a method to do this every single time if you aren't sure. You divide by the negative 2x on both sides, and then you sub it in for this part that you actually need. Okay, so if we're looking at this part, I'll go ahead and rewrite it so you can see that substitution I'm talking about. This was x e to negative x squared with respect to x. So this is what we're trying to substitute with because we already decided this was e to the u. So we can change our d of x to this expression. Okay, so right here, this would be du over negative 2x. And with that x, those cancel. There's where our negative 1/2 du is coming from. Okay, so now over to the side here, I'm going to rewrite it all together. So this part here, the negative 1/2 can come out to take care of the front, and we decided this was e to the u, and then we've got to have our du to the side. Okay, the antiderivative of the e function is just itself, just like when we are working with our derivatives. Okay, going the other direction. But now we'll just bring that constant down, and we know we have a constant that we have to go solve for using this ordered pair that we talked about earlier, and we can sub our information back in. So here we've got negative 1/2 e to the negative x squared plus our constant. That is our profit function, and we're ready to sub in. So we have the profit being 1 over 100, okay, and that's equal to negative 1/2 e to the negative. This right here is our 3 squared plus our constant. Okay, so I'm going to do this one in my calculator. Okay, but essentially we're just adding that over since this was a negative value. Now, because of this negative exponent, this is really just close to 0. Okay, that's something that hopefully you recognize when you have a negative exponent. It means a fraction 1 over something. And because this is a power function, it's going to be 1 over something pretty big on the bottom, which gets close to 0. So my constant is going to be this 1 over 100, but I want to show you that in your calculator so you can actually see what's going on here. Okay, so you could do this all in your calculator. 1 divided by 100, that's the 100th. Okay, 0.01. Okay, but then we're adding this over. We're adding the 1/2, so 0.5. Then our e to then this is 9, so negative 9th power. Okay, so it still rounds to 0.01. Okay, this is the decimal that was really close to 0 that I was talking about. It's 0.00006. Okay, very, very small. So our constant we're going to call 0.01 because it was really close to that. And then our final answer for our profit function is our negative 1/2 e to the negative x squared plus our constant of 0.01. And that's it.